Okay, so very good afternoon and welcome back. Well, we are discussing about the earth interior. In the earth interior, I was talking to you about the mantle. Is it audible? Is it audible to all of you? Okay. So, mantle I said is very dynamic zone I told you, and mantle have also some material rich in different metals like iron, chromium, etc. also there. And here ultimately what is happened if the tension and compression keeps continued forever, it will have crustal deformation, plate tectonics and almost all other things will be there. Crust page, sir, please open the crust page once. So, let me open this one. I have the crust page of the crust. Okay, some of you have asked for this. When the pressure is inversely proportional to the temperature, then how at the center or the innermost point tends to have high temperature with extremely high pressure. My friends, you remember here, it is a closed system or open system we need to see. Okay, it is a closed system or open system. Now look at here, if it is a closed system, pressure and temperature, they are, as you know, that directly proportional, you know it. Now, in this case, the same thing will work. What is the reason behind the thickness of the oceanic crust, that is the continental crust, different from the continental crust you should have, like why it is? Somewhere it is written like the oceanic and continental crust, why it is different? It is because oceanic crust is thin because of the depth here, and here it is continental crust, you have mountain, plateau, plain, etc., the thickness will be more, it is obvious thing. Now the question is, oceanic crustal thickness is varying from 3 to 10 kilometer. From where does lower crust start under the oceanic crust? My friend, you remember oceanic crust is very thin. There are a lot of ambiguity in your writings, particularly in the NCERT book here, but you remember the oceanic crust is very thin here, not the crust. Oceanic crust 3 to 10 kilometer is oceanic crust, and below this we have the lower crust. Oceanic crust is the upper crust itself, you remember this. As because oceanic crust is much thinner than the continental crust, what is the reason behind it? Reason is this is here is like crustal deformation is the major cause for this, and here it is made up of, they are no doubt it is thin here, but if you look at the weight of this material here in this particular case, it is denser material here you have, because mostly made up of basaltic material. Here it is only sialic, here it is basaltic, so it is a heavier one, they are compensating each other. Does silicon and aluminum are both in the oxide state? KSG book is giving aluminum, that is metal state. Yes, aluminum oxide stage generally in the upper part, metal stage in the lower part. Which is responsible for earth magnetic field? I will come to this now. Now we will go for rest of the things. So we did discussed about crust and mantle. Now I will go for the core of the earth. Core is the densest part of the earth. Core is the densest part of the earth. You know that this is the core. Core is the innermost and densest part of the earth. And remember, this core, as I just said, core is the densest and innermost part. Core, densest and innermost part of the earth's interior, densest and innermost part of the earth interior. It comprises nickel and iron, mostly nickel and iron. If you look at this entire regions here, like nickel and iron rich it is. Now this core is, as you know, the depth of the core from 2900 kilometer to the center of the earth, it is the entire regions is the core here, and core, if you look at their density of the core is highest here. Core density 13.8 to 9, in fact 11 to 13.8. Look at here, this is the core density. If I will go for the density of all these regions, here the density of this one, average density, if you look at 5, here it is 9 gram per cubic centimeter, here is 11 gram per cubic centimeter, 13.8 gram per cubic centimeter, 13.8 gram per cubic centimeter. Okay, 13.8 gram per cubic centimeter. So, the density gradually increases here. This is mostly made up of, I told you, nickel and ferrous. This is silica and magnesium. This is silica and aluminum. Sial, Sima and Nife. 3 areas you are having. Sial, Sima and Nife. 3 things you have. Okay. As I just said, if you will go deeper inside, gradually depth will increase. With the depth you have pressure will increase. With the depth there is increase in the density of the rock, density of the materials even. In this way gradually it goes on increasing down line. If you will go, there is increase in this, right. So, this is here I would like to say about the earth interior part here. Core, let us see now again. Let us move on to the core. Again I will go for the core part. This is the densest. It comprises nickel and ferrous, I told you. There are 2 parts of the core. Inner core and outer core, divided by the Lehman discontinuity. Inner core and outer core are divided by the Lehman discontinuity. You have already written this, Lehman discontinuity. Now, what happens here in the inner and outer core? Let us see now. The impact of, let me now go to next page. The impact of geothermal energy is more than the impact of pressure. Impact of pressure. Okay. So, 2900 to 5100 kilometer, from 2100 kilometer to 2100 kilometer to 5100 kilometer depth. So, it is in liquid stage. This zone is called as the outer core. Here the particles can move freely because geothermal energy is exceeding the impact of the pressure here. Geothermal energy exceeding the impact of the pressure. That is the cause geothermal energy is exceeding the pressure. That is the cause in these regions you have, like it is in liquid stage, outer core. Mostly molten materials are there. Mostly they are molten materials. from the rapidity discontinuity up to the center of the earth, the impact of pressure exceeds the impact of pressure exceeds the impact of geothermal energy. Again I am saying, from the rapid discontinuity up to the center of the earth, I mean inner core. Center of the earth means it is in the inner core. Rapid discontinuity to center of the earth, it is the inner core. It means it is the inner core. It means it is the, what is that? Inner core. Inner core regions. In the inner core regions, impact of geothermal energy is less, impact of pressure is more than the impact of geothermal energy. So, the particles cannot move freely, rather it oscillate from a fixed place, and behave like solid state of matter, behave like solid state here. Finally, the impact of, again I am saying, the impact of, you see here, from the rapid discontinuity up to the center of the earth, that is the inner core, the impact of pressure exceeds the impact of geothermal energy. So, the particles cannot move freely, rather it oscillates from a fixed place and behave like solid state. So, that is why we called it as solid. That is the cause we called inner core as solid. Okay. Both of these mostly consist of nickel and iron, or Nephe layer, as we know, it is the Nephe layer, NIFE, Nephe layer. We called it at the, it is composed of mostly nickel and iron, mostly composed of nickel and iron. So, it is known as the Nephe layer. It is also called as the Nephe layer, Nephe, NIFE, Nephe layer, nickel and ferrous, Nephe layer, composed of nickel and iron, Nephe layer. Okay. You must remember that the rapid discontinuity from there up to the center of the earth is the inner core. This inner core is in a solid state because of the more impact of pressure than the this one. Okay. So, it is given in NCERT 6378 kilometer, koi baat nahi, 5 kilometers, 6 kilometers, no problem at all. Okay. There are a lot of views because nobody has gone inside, so there is interpretation based on this. Okay. Bit of variation, it's okay. Because of seismic wave division, it shows dynamic, mental plume. Okay. Let me see what are the question. You have a question here like, when region, what is thickness you got it. Are upper mantle convection asthenosphere same? Kopheschema, yes. Kopheschema, as you said, are upper mantle Kopheschema asthenosphere. You see the eclogite formation is there in the upper the asthenosphere stage. Asthenosphere is the region where you have, yes, you have Kopheschema regions there you having it. Yes, it is. If the sinking of part of image you draw is weak, so molten will coming out. sinking part of the image. I haven't got it the question. How the rapidly CCC moves means rate of flow, how it affects the number of times of occurrence of earthquake. My friend, convection current theory, it is a part of geology, and convection current, these are like, the continuous flow is there. The rate of movement differ with respect to the presence of radioactive materials and different different composition of the metals in that particular region, metals and minerals in that regions. Are there defined or identified specific area of crustal deformation or anywhere on the crust where can be crustal deformation? Crustal deformation will be there wherever there is tensional force or compressional force. There are defined areas only. Wherever plate convergence or divergence is there, in that region you have crustal deformation. Can the convection cycle cells changes position with respect to crust? Convection cycle changes with respect to Earth's sun's magnetic field even, and Earth's magnetic field. Will the place of comprehensive and tensile forces stay at the same place under the crust all times? No. Is mantle total liquid or sometimes solid? See, mantle is sometimes, in some area it is solid, somewhere it is liquid. It is very variable, I told you. Are there any country mapping today? Yes, why not? Is there any layer between lithosphere and asthenosphere? That is the part of, lithosphere, asthenosphere, there is no part of the upper mantle is there. Yes. How is it possible, sir, when asthenosphere move, then lithosphere move same side, there is no frictional force in between. Okay. Sir, is it Repetier Lehman? Lehman it will be. CMRGL. Lehman discontinuity it will be. Sorry, if I said. Lehman discontinuity, Repeti लिखा है क्या? Just 1 minute please. From this is Repeti नहीं है, Lehman. You know it better than me now. Thank you very much. Lehman. Lehman होगा ना? Lehman discontinuity. देखो यहाँ पे. Here you see. Please. Look at here, I have given here Lehman discontinuity. Please look at here, inner and outer core Lehman discontinuity. Can you please rectify? Thank you very much, my dear, who have pointed out this. Thank you. Elastic zone means soft zone which can absorb the stress here. I just want to know if there are any relationship between mantle plume or Earth's core and Earth's electromagnetic field, so how they form. Yes, it is. I will explain it. Sir, are radioactive elements also present in outer core? See that we have very less knowledge about outer core. Yes, it is found. There are few things remains radioactive materials. We have less knowledge about this, but there is possibility of this, as the geoscientists are saying. Based on the different tests, we are getting the practically speaking, you don't have much more idea about this, but based on interference and different logic, they are saying there is presence of this. By the way, is Lehman discontinuity, please? Outer core and inner core is Lehman discontinuities. Can you please see these things? Lehman, here I have written Lehman and here I have written Lehman, and now it is Lehman discontinuity. Lehman discontinuity. Okay, fine. Nife composite nickel and iron. Fine. As I just have mentioned about this inner core and outer core, now you think about certain thing more like, okay. If the earth is like, we have the inner core here, outer core, inner core, we have the mantle here. This is the inner core. Here it is the outer core, and here it is the mantle, and here it is the crust. These are like this: crust, mantle, outer core, inner core. Now think about certain thing like, in which you imagine a case like you have the entire materials found here in these regions. Okay. The inner core and rest of the earth, inner core and outer core, they are made up of metallic material, no doubt. Now, inner core and rest of the earth, they are moving in the same direction, but in differential velocity is there. Velocity of inner core and rest of the earth is different. So, what will happen? Because of this movement, there is development of magnetic field, electric magnetic field here. Does the nickel and ferrous of Nephi layer stay in oxide form? It is in metallic form. Is the velocity of P wave and S wave through the earth indicate that the earth has a solid inner core? Yes, that's why only there is deflection there, na? That is the cause. Okay, now look at here. Because of the differential movement of the inner core and the rest of the earth's magnetic field developed. Note down this point. Due to the differential movement of the earth's metallic inner core and metallic liquid outer core, magnetic field of the earth developed. Magnetic field of the earth developed. Because of this only the magnetic field of the earth developed. This leads to the formation of the earth's magnetic field. Earth's magnetic field developed due to differential movement of the inner core and rest of the earth. Inner core and rest of the earth. Let us see now. Look at here. This leads to earth's magnetic field here. Why? The differential movement of, I said, the inner core and rest of the earth. This is the inner core and rest of the earth. Differential movement leads to this type magnetic field here. This is earth's north pole, but magnetic south pole you see. Here earth's south pole, magnetic north pole you will have here. Can you see this? Depiction of earth's magnetic field as a bar magnet coinciding with the core. The south pole of such a magnet points to the earth's north pole. The red arrows represent the orientation of the magnetic field at various locations on earth's surface. Magnetic field is different location at earth's surface, it is there. But you remember, this is the magnetic field which you will get. Sir, is the velocity of P and S wave? Okay. Please use Hindi language when you are going to teach the term. It is more easy to understand, sir. Okay. You know Hindi? Good. Okay. No problem. We will do that. Because most of you have no idea. I think you will not able to get the things properly. So I am not saying. But still, अगर जरूरत पड़ेगा कहेंगे, कोई दिक्कत नहीं है आप. Okay. I have given those who don't know Hindi or have problem in English, you can send me recorded voice. Okay, I have given the number also, and ask me in Bengali also. I will understand. Okay, मैं try करूँगा समझने के लिए, समझ जाऊँगा. Okay, and I know that if there is a difficulty on expressing certain things, please you can do that. No problem. Look at here how it is. North and South pole. North pole is this one, south geographic pole, Earth's north pole and south. Now, there is a difference between Earth's magnetic field and the lines here. If you look at, this is different also. You see here. देखो इसको थोड़ा सही से. Geographic north pole is right side, north magnetic pole is 11.5 degree difference. Some books are saying 21 degree differences. कुछ बुक में क्या है ना 21 degree difference भी लिखा है. Look at here. This is north magnetic geographic north pole. This will be magnetic south pole. Okay. In a bar magnet we have given this. Magnetic pole. There is a difference of 11.5 degree, I said. Geographic south pole, geographic north pole, magnetic south pole, magnetic north pole. You are saying this particular, in case of a bar magnet, it is there. Magnetic field and bar magnet, many a times you know what is there, north, this pole and this is here, you know, these two part, while this particular distance here, 11.5 degree. 11.5, 11 and a half degree. Okay. Hey, don't worry. Some Hindi, some English, कोई दिक्कत नहीं है, कर लेंगे 50-50. Don't worry. Okay. Does mental play a role in generating magnetic field due to convection currents? See, we have again about this, इसके बारे में भी अभी तक कोई ठोस सबूत नहीं है, but हो सकता है. Technically speaking, there is possibility of this. See, bar magnet को लेंगे तो वैसे होगा ना. Usually we, in the layman sense, we are using this like this. देखो ये दिया है ना, layman sense. We go for this. Layman sense, north magnetic pole बोलते हैं और geographic pole है. But practically in scientific way, as I have just mentioned earlier, पहले हमने mention किया था ना, ये देखो, south pole and north pole. What is that? Earth's north pole and Earth's south pole. This is bar magnet. If you look at, it will be like this in this way. So on that aspect it is said. Anyway, the magnetic field is there. Geographic pole and magnetic pole, they have different because the Earth's rotation, and we came to know one very interesting thing. This north pole became south pole became north pole also. Magnetic north pole, now it is, if it is north, it will gradually it will come in this way. The pole will come in this way. North become south, south become north, known as a complete reversal of the pole, polar reversal. Pole generally changes. Lot of things which is not properly understood yet, that why it is, but yes, there is a change in the magnetic field. Okay, here another question here. Why the remaining part of mantle above asthenosphere is not suitable for convection current in spite of being in liquid state? Who said it is in liquid state? It is not in remaining part of above asthenosphere, not in liquid state. It is not in liquid state. Okay. A variable, I said, entire mantle is variable, not in one particular state. You remember this point. So this is something about Earth interior. I tried to give you some idea what type of question you will get it. Let us see now. Type of question asked from this particular part now. What type of question you will get it from this? Let us see now. Okay. देखते हैं क्या question आएंगे. What type of question you will get it? So first question I am giving you. Please write first question. For the main exam I am giving. For the prelim, they will give you questions. चलिए, first for prelim, let me give you 4 or 5 questions. Let us see how we will go for this. Like a quiz, I will give you some questions here now immediately. Like number 1, they will give you questions. Which one among the following pair is correctly matched? which one, consider the following pair. Okay, first is consider the following pair. Consider the following pairs. If I'll go for quiz, it will be like very easy for you, hai na? So let me make it a bit difficult. Consider the following pairs. Asthenosphere, low velocity zone, MOHO discontinuity, mantle and core. Oldham discontinuity, inner core and outer core. We have Repeti discontinuity, upper and lower mantle. Upper and the correct statements are one and two, 1, 2 and 3, 1 and 4, none of these, okay. What will be the answer now? Tell me. 1 and 4 are correct, somebody is saying. 1 and 4 are correct, somebody is saying 1 and 4. Okay, very good. Some of you said like 1 and 4 mean B is the correct one, isn't it? So questions will be on the discontinuity, questions will be on the state of the matter. Consider the following statement, like state of the matter also they will ask. Questions will be on again the low velocity, where refraction is there, at which particular depth refraction or bending of the shadow zone. Questions will be on shadow zone also, shadow zone. So you can go for P wave shadow zone, P wave 105 to 145 and S wave is 105 to 105. आप ये करिए, or we can write even 143 to 103 to 143. In some books in 103 to 143. 103 to 103 it is given, but 103 is not correct here, not completely acceptable. So you go for this and you go for this one, these two. आप इसको देखिएगा, you will get it. Now same way as I have just given one question, so we can have like inner core, outer core, the difference between the north geographic pole and the magnetic pole. Angle is 11.5 to 21. Now they are saying 21 degree even. Recent findings say that 21 degree, but not, it is not, it is published in research paper, not in any textbook. So 11.5 which I said is the till date in the textbook which is there, you need to follow that. Well, we need to see now another important point here. In the mains exam, question number 1 I am giving, first assignment I am giving you is give a detailed account on the physical conditions of the Earth's interior in the light of seismic evidences. 12 marks, 150 words. Question number 2. Briefly discuss the tripartite structure of the Earth's interior and with its general characteristics. Briefly discuss the temperature of the Earth's interior and its physical structure and its structure. We will discuss the tripartite structure of the Earth's interior with its physical structure and along with its structure and composition. 12 marks again, 150 words. We are not getting this question nowadays. This type of question is, this first one is important and the second one. Briefly discuss the tripartite structure of the Earth interior along with its structure and composition. So we need to see these things. Try to write this and upload in the portal for evaluation. You will get the evaluated copies with whatever wrong, what is there, what is the problem and all. You will get to know. At least one question you write. Let me tell you what you need to do on this. First thing, you will get the feedback no doubt on this while you write and give the answer. Give a detailed account on the physical condition of the Earth interior. Now what you have to do, detailed account. You need to just give some different sources from which you are getting about the Earth interior, information about the Earth interior. We have focus will be on seismic evidences, particularly seismic tomography, where you need to say the characteristics of the seismic wave. Then you go for interpretation, travel path and interpretation of the seismic wave, based on which we have no homogeneity, there is heterogeneity, there is crust, mantle and core, and with some distinctive what you call zones. Okay. So what are those? You have to see, you have to write down draw the diagrams and do it. And this is direct question, so you have to write like crust, mantle and core in detail, nothing else. These are very easy things. These are very easy things. So this is something about your today's earth interior. Is it okay to all of you? Reference for both is your KSG materials, if you have an materials, and the NCERT which you have, these two. क्लास नोट के साथ साथ यही कर लीजिए. विद द क्लास नोट यू कैन गो फॉर दिस ऑल्सो, नो प्रॉब्लम. इज इट क्लियर टू ऑल ऑफ यू? कैन आई गो फॉर द नेक्स्ट टॉपिक? एनी डाउट्स ऑन दिस प्लीज गिव मी. इस पे क्या डाउट्स है बताइए. प्लीज गिव मी द डाउट्स व्हाट एवर यू हैव ऑन दिस पर्टिकुलर टॉपिक, अर्थ इंटीरियर. प्लीज गो अहेड. इफ एवरीथिंग इज ओके से फाइन, ओके, नो प्रॉब्लम. You got it said, you got it, or give me if you have any doubt, any question. Is it okay? Clear? Is it clear to all of you? Is it clear to all of you? Should I go for the next? Yes? What are rocks? Rocks are aggregates of minerals, we know. These are the aggregates of minerals. These are the aggregates of minerals. This only for preliminary exam, for preliminary only. Rock chapter is only for the preliminary, okay. Now, aggregates of minerals is called as a rock. Rock are of different types. Generally there are, in general, there are 3 types of rocks. What are those? 1, igneous rock. Second, sedimentary rock. And third, metamorphic rock. So we have 3 types of rocks: metamorphic, sedimentary and igneous rock. 3 types of rocks you have: igneous, metamorphic and sedimentary. Now the question is, how the igneous rocks were formed? How the sedimentary, what is the characteristics of the metamorphic rock? What is the metamorphic rock, how they form, characteristics of this? So one by one, in the preliminary exam they are asking this, so I will go for this in detail one by one. All these rock types we will discuss in detail one by one. Okay. So first one, igneous rock, is not it? First one is your igneous rock. Do you know that these rocks are fundamental rocks? These are derived from the magma or lava. These are derived from the magma or lava due to solidification, cooling and solidification of magma, cooling and solidification of magma or the lava leads to the formation of igneous rocks. So, the igneous rocks are formed due to solidification, cooling and solidification of magma or lava, cooling or solidification of magma or lava. Because of this they form. So, that is why the first rocks formed over the earth surface is igneous rocks. So, it is called as the fundamental rock. First rock formed over the earth's surface is igneous rock. So, it is called as the fundamental rock. First rock which is formed over the earth's surface is igneous rock. So, it is called as the fundamental rock. Okay. Almost all other rocks are derived directly or indirectly from the igneous rocks. So, it is called as the primary rock, primary rock. It is called as the primary rock. Almost all other rocks are derived from directly or indirectly from the igneous rock. So, it is called as the primary rock. Earth's crust is first developed with the igneous rocks. So, it is called as the basement rock or universal rock. So, there are different types of name for this, basement rock or universal rock, primary rock, fundamental rock, foundation rock. So many things are there: foundation rock, fundamental rock, primary rock. This is igneous rocks. So, igneous rocks, they are of different types. Some of these are rich in, some of these rocks made up of basaltic material. Some of these rocks made up of acidic lava. Their behavior will be different, they are of different type. Some of them you will get it on the earth crust, upper crust itself, some of them inside the crust, inside the soil, it is inside this. So, there are different types of igneous rocks you have. There are different types of igneous rock I am saying. So, let us see now again और क्या क्या है देखते हैं. The igneous rocks, most common examples of igneous rocks. Igneous rocks are of two major types. What are those? One, the extrusive igneous rock. Extrusive igneous rock. Another one is intrusive igneous rock. At extrusive and intrusive igneous rock, two types of igneous rock, intrusive and extrusive. दो तरह की है. Where you will get intrusive, where you will get the extrusive rocks. Let us see now. Let us say this is a place here, and on this you have, let us say here is a mountain, here is a plateau, like plain you have, different things are there. What are intrusive igneous rock? What are extrusive igneous rock? The rocks present on the earth's surface and below the surface. On the earth's surface, these are here extrusive. These are intrusive. What are extrusive? What are intrusive? Let us see now. बार, बार कहाँ है? ऊपर है. कौन गया? DGP Gabbro. Will you be able to memorize this? Gabbro. DGP Gabbro. Basalt, andesite, rhyolite. These are the rock generally you will find over the earth's surface, but inside diorite, granite, peridotite, grano, diorite, gabbro. These are the intrusive rocks. You will get these intrusive rock in the earth. Inside you have the intrusive rock. Diorite, granite, peridotite, granodiorite, gabbro. These are the intrusive rocks. Basalt, andesite and rhyolite, these are the extrusive rocks. Extrusive and intrusive, two types of rocks I have said. Extrusive and intrusive, two types of rocks you know. Is it clear? Basalt, andesite and rhyolite, extrusive. Diorite, granite, peridotite, granodiorite, gabbro, intrusive. Two major types of rocks you have. I hope all of you got it. Name only you have to remember. Very important. You must remember the name. Name of all these is very, very important for you. A interesting question, I got it here from someone. Sanjay, I have a question. How we get the readings of waves from the one part to another part of the earth surface that passes through the interior of the earth? My friend, wave motion, wave goes inside, that is the only cause. Wave, nothing else. Clear to all of you? Okay. No other question here. Fine. So, I said basalt, andesite and rhyolite, they are three, these are the three extrusive rocks. Diorite, granite, pedotite, gabbro, granodiorite, they are intrusive rocks. They are of different form. What are the characteristics of these rocks? Let us see now. What are the characteristics of the rock? Now, you tell me which one will be more fine texture? किसका होगा fine texture? Extrusive or intrusive? Where you have fine texture, texture will be very fine. Where you have the fine texture, बताओ. Fine texture of rocks. Which one? Extrusive or intrusive? Somebody said first slide of the rock, aggregates of minerals in general, these are of three types: igneous, sedimentary, metamorphic. This much only, right? Again I said this derived from the magma. I told you about this, if you remember. Your friend is saying, someone is saying extrusive. Fine texture of rocks in extrusive or intrusive? Extrusive. Are you sure? Because I have written here. Or what? Why it is extrusive? Can anyone tell me? Why, if you are saying extrusive? Extrusive. Yes? Somebody is saying, sir, when are we supposed to submit these answers? By Monday, coming Monday. Monday you have to give it, Monday. Intrusive क्यों होगा? Extrusive is correct one because you know what happened? They cool down very quickly as compared to the intrusive. Erosion weathering नहीं. It is because it solidified very fast. Yes, of course it is correct. Extrusive because extrusive, fine texture, because suddenly it cool down and it breaks finer particle. But here it gradually cooling of this intrusive rock takes place, and these you have like what type of texture you have? Granular texture or coarse texture you have. Finer one, here is coarse texture. One is amorphous, another one is, you know that the texture will be fine texture here, but here it is granular texture. Intrusive will have the granular texture, extrusive we have the fine texture. That's why अरे भाई ग्रेनाइट को क्यों यूज करते हैं? ग्रेनाइट इज यूज एज लाइक मार्बल, वी आर यूजिंग दिस. इसको पॉलिशिंग करने से शाइनिंग होता है ग्रेनाइट. दैट इज द कॉज बिकॉज इट हैव ग्रेनुलर टेक्सचर. ओके, रेपिडो कूलिंग, हाँ ठीक है, फाइन. एक्सक्लूसिव विल बी द करेक्ट वन. ठीक है, फाइन. नाउ यू हैव टू फाइंड आउट, यू मस्ट हैव सीन बसाल्ट. बसाल्ट तो बहुत कॉमन है, देखा होगा. एंडीसाइट इन द माउंटेनस रीजन, रायोलाइट ऑल्सो यू विल फाइंड. डायराइट, ग्रेनाइट you will get it. Granite rocks which we are using in the building stone and all, pedotite, so all these are there. Okay. So, what are the other characteristics of this? Let us see now. What are the other characteristics we will see now? Second point of igneous rocks are generally rich in the metallic minerals. Metallic minerals. Igneous rocks are generally rich in metallic minerals. They are rich in metallic minerals. Igneous rocks are generally rich in metallic minerals. Igneous rocks are generally rich in metallic minerals. So, you can get like iron, ore, gold, silver, copper, bauxite, all these things are. Aluminum rich materials, copper, tin, etc. You will get it from here. Igneous material. Next one, igneous rocks are less affected by chemical weathering, but mostly affected by physical weathering. Now the question is, what is weathering? Weathering क्या होता है? Can anyone tell me what is weathering? Among you, can anyone tell me what is weathering? What do you mean by weathering? What is weathering? Can anyone tell me? Yes. Can anyone tell me what is weathering, please? Disintegration and decomposition of the rocks in situ is known as weathering. Don't you remember? Don't you know about this? You do one thing. You prepare a separate box now. I need at least half a page on this, okay? Half a page. आधा पेज का एक बनाइए, खाली नीचे मत दीजिए, ऊपर ही ऐसे करिए. आई विल गिव यू सम डिटेल ऑफ द वेदरिंग बिकॉज आई नीड लॉट ऑफ थिंग्स ऑन वेदरिंग. वेदरिंग क्या है? और यू कैन पुट ए स्टार मार्क एंड राइट डाउन weathering. Weathering is, you can note down here, disintegration and decomposition of the rocks. Rocks in situ. In situ means in a fixed place. Somebody said conversion of igneous rock slowly into the sedimentary rocks. Hey, wearing and tearing of rocks by various erosional agent. Erosional है तो erosion होगा. How it will be weathering? Corrosion by wind, air, water. Oh, disintegration of rocks. Yes, thank you. Disintegration of rocks, very good. Thank you. Breakdown of rocks, very good. Disintegration of rocks by weather phenomena, very nice. Thank you. Where wind and water acting upon the rocks. No. Corrosion, no. Wearing down. चलिए, in situ decay and decomposition. Yes. Okay. Don't worry. You will get to know gradually. कोई बात नहीं. Example दो. I will give you example. Lot of examples you will find out. Disintegration and decomposition of rocks in situ in a fixed, in situ mean in a fixed place is called as weathering. Is called as weathering. Now, as I just said about the disintegration and decomposition of the rocks in situ, if I will go for the types of weathering, how many types of weathering? Types. There are three major types. Physical weathering. If the weathering is due to physical factor, if the weathering is due to physical factors like temperature, pressure, humidity, etc. Temperature, pressure, humidity, etc. The most common one is physical weathering. My friends, in the desert region, particularly in the hot desert regions, Sahara desert you have. In the Sahara desert, you will get sand. In the Sahara desert region, we have sand. Sand in the Sahara desert. कैसे आया? कहाँ से आया? Disintegration of the rocks leads to this. During the daytime, temperature is very high, so expansion of the rock takes place. During the night time, temperature became very low, so contraction takes place. Expansion and contraction of this, repetition of this leads to fragmentation of the rocks. Crack develops on this and it got fragmented. This is what is weathering, physical weathering. Some of you must have visited Jaisalmer area, third desert regions of Jaisalmer, Rajasthan. There are few places in Rajasthan desert, राजस्थान की मरुस्थल में कुछ जगह ऐसा भी है. There are some places where in the night if you stay in this desert area you will find cracking sound. जैसे कि पॉपकॉर्न खा रहा है कोई, है ना, cracking sound. Why? In the night what happened, because of low temperature, these rocks generally condensed, compressed, contraction is there and breaking of the rock takes place. इसीलिए cracking sound होते हैं. You will get these things mostly in Stuart Stony Desert of Australia. Australia की Stuart Stony Desert has this type of characteristics also. So these are like, the region where high temperature leads to in the daytime expansion of the rocks. In the night you have low temperature lead to contraction. Expansion and contraction leads to cracks and development of this. These got subsequently, the rock crystal, rock, fragments, they got again got refragmented and smaller units. Maybe you have coarse texture and may have finer gradually to sand even. This is one, physical weathering. I hope it is clear to all of you. Second type of weathering, chemical weathering. Chemical weathering. Chemical weathering. Chemical weathering. Yes. Why? In the winter your leaves, cracks on the leaves with their leaf. Cracks hota hai. Why? Best example here. Temperature became less. Dryness is there. That is the cause. Cold and dry conditions. Weathering. Chemical weathering. Cavity formation. Dant mein, in your teeth you have cavities in your teeth if you have. Is glacier also have phase, physical weathering? Phase? What do you mean by phase? No, glacier is erosional one. Glacier is erosional one. Okay. Movement of glacier. Chemical weathering is nothing but disintegration and decomposition of the rocks due to chemical reaction, chemical action. Like you have carbonation. Carbonation is a very good example. Sodium chloride, chalk or limestone rich region in which you pour water into it. Solution. Dissolving of the solute, the material got dissolved there. Salt hai ya sugar is there, you pour water into this salt and you have formation of cavity. In the limestone rich region there is cavity formation. Is a very good example of chemical weathering. Limestone rich regions has, in the limestone rich region, what is there? In the limestone rich region we have cavity formation. The best example here, limestone rich regions has cavity formation. Best example, chemical weathering. Cavity in your teeth, I said, chemical weathering. Weathering helps in erosion. भाई दांत कैविटी हो के बाद में इरोजन होके निकल जाएगा. Erosion. Weathering leads to erosion. The rocks become very loosely bound, then you have erosion will be very easy. Weathering leads to erosion. Weathering leads to erosion. I hope it is clear to all of you. Carbonation, solution, as I said, chemical weathering. Best example I have just tried to give you. Cavity formation in the limestone rich regions due to the impact of groundwater. Due to the impact of groundwater. Chemical weathering. It is chemical weathering. chemical weathering. Third one is biological weathering. Due to the impact of plant and animal, living beings. Plant, like this one you need pre-slide. Okay, you got it now. Please note it down. Is it clear? Cavity formation in the limestone rich regions due to the impact of groundwater, I have said. Done? Next one, biological weathering. Due to the impact of plant and animal, influence of plant and animal. Plant, like tree roots in the old fort or building or rocks, splitting the rocks. Splitting the rocks, we have sometimes the tree roots are splitting the rocks and they weaken the rock strata. Well, you can see that is a very good example of biological weathering. Animals like earthworm, rodents, rats, like rat and earthworm, like earthworm wherever is there, केचुआ, जिया, केचुआ क्या बोलता है, केचुआ, जिया, earthworm. The pH value of the soil is different there. The pH value of the soil is different in that case. And very interestingly, you have a as I just said about this, like biological weathering due to impact of the plant and animal. Animal plays a very important role here. Weaken the strata. This is biological weathering. Now you tell me one thing. Some of you must have experienced. In a hair you have dandruff. Have you seen the dandruff? Dandruff is a what type of weathering, you tell me? Dandruff is the symptom of weathering, biochemical weathering, is not it? And after this you will have erosion, complete erosion. Weathering leads to erosion. You remember? Take care of your here you see weathering leads to erosion. I hope you got very good example here. You are not going to forget this erosion, weathering part at least. Weathering helps in erosion, I told you. Well, once it is done, weathering helps in what? Weathering always helps in the formation of different type of soil formation. Weathering leads to formation of the soil. Different types of soil fertility depends on parent materials and the weathering. Right? Weathering helps in erosion, I said. So as I just mentioned about this, let me again go back to the property of these igneous rocks. Weathering, igneous rocks are less affected by chemical weathering, but mostly affected by physical weathering because of this igneous rocks. They are metallic mineral. Igneous rocks have no distinctive layer. There is absence of distinct layers or zones in igneous rock. Fourth point, in the igneous rocks. Igneous rocks you will not get this. Igneous rocks you will never get distinct layer. Generally igneous rocks are generally denser, compact and less porous. Less porous. Hey, biological weathering is one type of physical weathering and chemical weathering both. How it will be? No, not at all. Biological weathering is because of the action of flora and fauna. Okay, mechanical action is there and so many things. In the weathering, even if there is more heavier material is there, okay, and the heavier material got eroded consequently, so pressure will be less, due to which, like onion peeling, you know, layer by layer weathering also takes place, which are called as exfoliation. Okay, exfoliation, weathering type, weathering, एक्सफोलिएशन कहते हैं जिसको, EXFOLIATION, exfoliation. Onion peeling weathering, as if you are peeling the onion. Okay, so biological weathering is one type of physical weathering, chemical, no, not at all. Biological weathering is completely different from physical and chemical weathering. They are mechanically, in fact, because you are talking about natural environment here. Okay, so that's why. Point number 4 to repeat it. Okay, there is absence of distinct layers or zones in the igneous rock. I mean, you will not get layer by layer formation at a time. There is no division of layers here. But in sedimentary rock, you have layer by layer. Okay. Igneous rocks are generally denser, compact and less porous. Porous is only one, pumice. 0.5 means that these types of rocks do not have too much capacity to holding water. Yes, they are less porous. See, holding water is not only porous, permeability also there. Porosity and permeability are two different things. You know, clay is porous but not permeable. पता है ना? Porosity and permeability, two things. अरे भाई, clay, मटका जो है ना, मिट्टी का मटका, कुल्हड़ में, कोलकाता में चाय मिलता है, अगर कुल्हड़ वगैरह दैट क्ले इज पोरस इज परमिएबल होगा तो चाय कैसे पिएंगे? इट विल गोज डाउन. इट इज पोरस बट नॉट परमिएबल. सो इन दैट केस, यू नो, पोरोसिटी परमिएबिलिटी डिफरेंट. बेस्ड ऑन परमिएबिलिटी, porosity and permeability both, if you have permeability is there, you have like capacity of holding water, porous and permeability. So you see that these are very important to know. Okay. Acid rain is what type of weathering? Acid rain leads to, it will bring chemical weathering. Acid rain brings chemical weathering. Okay, chemical weathering. Okay. Igneous rocks are generally denser, compact and less porous. Okay, these are certain things about, because it is less porous and permeability is less, that is why only you have like, you know, it is less affected by the chemical weathering, more affected by physical weathering, less by the chemical weathering, because the chemicals cannot go inside because of less porosity and permeability. This is here. Fine. I hope it is clear to all of you. Now, let us now move on to the next. Okay. We have, one thing I was supposed to tell you in the beginning, but I forgot. Let me let me remind you certain things. First point is, we got some feedback from you people. First, regarding whether you have to join these classes from your, is it possible to join the classes from your residence? घर में बैठे क्या हम ये क्लास कर सकते हैं? We have already given this information to concerned authority. ATI में बताया गया है. You will get very soon whatever decision they will have, they will tell us. Okay, बहुत जल्दी मिल जाएगा उसके ऊपर. We have already conveyed the things, don't worry. Second thing, about another request I got, we got it from you people regarding use of Hindi sometimes. I am using that. I hope आप लोगों को समझ में आ रहा होगा. नहीं होगा तो बताओ, मैं immediately I react to that. Okay. If you have any specific problem also, I have given this number also. You can call me or you can WhatsApp me if required. Okay. Don't worry. We have already conveyed the things. Just आप कंसंट्रेट करिए पढ़ने में. मटेरियल विच यू गॉट, जैसे हम बोल रहे हैं, पढ़ाई करिए. और जो क्वेश्चन का आंसर के लिए बोला मैंने, बाय मंडे, यार मंडे यू कैन गिव, लास्ट बाय मंडे, कमिंग मंडे यू गिव दिस क्वेश्चन आंसर. ओके, आफ्टर मंडे यू विल नॉट इवैल्यूएट ऑल दिस. बाय मंडे यू प्लीज डू इट. Okay, so I request you all to see this, and I hope that you will able to do. I hope it is clear. So let us now move on to the next characteristic. These are the characteristics of igneous rock, I said. Let me now move on to the sedimentary rock. Sedimentary rocks. Sedimentary rocks, what is the speciality of these rocks? These are derived from igneous, metamorphic or even the sedimentary rocks due to weathering, erosion and deposition of sediments. These rocks are generally derived from the igneous, metamorphic and sedimentary rocks due to weathering, erosion and subsequent deposition of sediments. Deposition of sediments. Subsequent deposition of sediments. Weathering, erosion and subsequent deposition. Second point is, these rocks are found in layers due to the process of sedimentation and lithification. Sedimentation and lithification. Due to the process of sedimentation and lithification. What does it mean? What do you mean by sedimentation and how it is different from lithification? Sedimentation and lithification, I said. Do you know about this? Have any idea about sedimentation process, lithification process? Sedimentation, lithification. Let us see. Weathering, erosion and deposition. Weathering, erosion and deposition leads to what is that? Sedimentation. Sedimentation leads to compaction. Yeah, lithification, sorry, lithification and the compaction. Lithification. Then we have compaction. Then we have sedimentary rock formation. Weathering, erosion and deposition, sedimentation, sedimentation, lithification. Yes. Very good. Splitting, process of settling, yes. Compaction, sedimentary rock formation. Example of sedimentary rocks. Can anyone give me examples of sedimentary rocks? Examples? Yes. Sand, sandstone, limestone, shale, gypsum, salt, coal, petroleum. Petroleum is a rock type, mixed with different things. Petroleum, sedimentary rock, shale, gypsum, salt, coal, sand, clay. All these things will comes under chalk, limestone. Limestone is there, chalk. All these things will comes under, it is sand, sandstone, limestone, shale, gypsum, salt, coal, petroleum, clay, chalk. All these are good example of sedimentary rock. Lithification and sedimentation. See, a transition zone between sediments got deposited, deposition हुआ, and lithification. This is a transition zone. Sedimentation, unsorted deposits here. Sediments, lithification, there will be particles will be bit close here. In compaction, completely they got in layer by layer formation. Layering starts in lithification and completed in compaction. Sedimentation is only loosely deposition of materials from the parent rock by different agents of erosion or by different action you have. Okay, so these are different things here. So the sedimentary rocks are that's why generally associated with sedimentary rocks are generally associated with sedimentary rocks are generally associated with what? Presence of non-metallic minerals. Non-metallic minerals. Metals you will not get with these sedimentary rocks mostly. Non-metallic mineral you will get. They are associated with the presence of non-metallic mineral first. Sedimentary rocks are associated with the presence of non-metallic minerals. Okay. What else? Non-metallic minerals you have, whether it is petroleum, natural gas, or go for any of the most of like chalk, you have limestone, you have dolostone, dolomite, all these things. Slate is not sandstone. Slate, shell leads to slates. Metamorphic form as slate. So another one, sedimentary rocks are I say generally associated with the presence of non-metallic minerals. These rocks are mostly porous and permeable. Mostly I am saying porous and permeable. So generally affected by chemical weathering. They are mostly affected by the chemical weathering. These are mostly affected by chemical weathering. They are mostly affected by the chemical weathering process of chemical weathering. Sedimentary rocks. These rocks are weak or weakly developed and prone to erosion. Soft rock these are, prone to erosion. You see that even the rocks like because of the water, flowing of the water, you have deposits of eroded materials and formation of different layers of sedimentary rocks. Sedimentary rock they form layer by layer, also they form sedimentary rocks. These sedimentary rocks are argillaceous, which is called as because of river water. If it is because of water, argillaceous we called it. But anyway, you can say these rocks are generally associated with non-metallic minerals, weak these are, and there is great variation in its strength, the very weak these rocks are. Achha, by the way, by this time you can give the questions even if required. Okay, in between you can put question if required. So sedimentary rock you got it. They are weak rock. They are mostly weak rock. Okay. Now we have another one is third type of rock is metamorphic rock. metamorphic rock. Very nicely given in your NCERT book. If you have studied, it has given what is metamorphism. Change in the arrangement of the particles is there due to pressure and temperature. This is called as the metamorphism. Chemical alterations is also there sometimes. Not only physical alteration, chemical alteration also there. Chemical compositional variation also you have. Mostly due to the temperature. Okay. So, oh, lot of question now I am getting. Okay, okay. Let me take the question first. Metamorphic rock tomorrow we'll do. Questions, lot of questions you have. Let me do this. Okay. Tomorrow I'll go for the metamorphic rock because we have less time. Lot of questions are there. Was not ever. Okay, fine. Let me take the question now. First is, how much time required for conversion of north magnetic pole to become the south magnetic pole? My friends, Vine and Matthew, there are two people, scientists, who first time said there is magnetic reversal, geomagnetic reversal. It takes millions of years in fact, and this is not a fixed time period. Every year why it shifts, sir, please explain. Every year it shifts. The shifting of the magnetic field is not yet confirmed why it is, but still we have seen this is related with the Earth's internal disturbances, and some people are saying about the sun, solar storm and the sunspot cycle activity also, but we don't have any correlation. Rather, the Earth magnetic field is there changing because of the differential movement of the inner core and rest of the Earth. There are certain things like paleomagnetism and geomagnetic reversal. In the continental drift tomorrow I will discuss about this, why it is there. But people believe like, this Vine and Matthew I told you, they believe like, the reversal of this one in a periodic way, because whenever there is any material reaching the Curie point, after that you have like magnetic power of that metal will completely lost, then again regain after it cool down. So, that temperature while it attain, and later on it will have like, different orientation. Tomorrow I am going to discuss about this with some diagrams, illustration, etc. in continental drift concept. So, just wait for that. How you get the reading of waves from one part to another part of the earth surface that passes through the interior of the earth? See, as I said, how you get to know about your X-ray or while MRI CT scan you are doing, you are getting the impression same way. So, there are there are different type of model through which you are getting. Have you ever seen how you go for underground drilling? कैसे करते हैं हम लोग drilling कैसे करते हैं? How you ever get to know about the different minerals present at the deep surface? Same way it is. In which layer is the focus located on an earthquake? My friends, it can be up to just above the asthenosphere only, in the lithosphere only, entire lithosphere, it can be anywhere. In the volcanic mountain, the intrusive igneous rocks are developed or the general surface. In the volcanic mountain, intrusive igneous rocks are developed, also in general surface wherever weakness is there, like if volcanic eruption is going on, you have above you have very hard crust. So, the magma intruded below and it goes inside and it got deposited, huge dome like structure of magma, they got solidified in this form, okay, they form this. We will have a discussion on volcano. At that time, I will again go for the volcanic rocks, this type form, like laccolith, phacolith, baccolith, you have like phacolith, we have batholith, dike, seal, etc. We will discuss in the volcano part. Can you please clarify concept of polar reversal and why does it happen? Tomorrow we will do. Please explain geographic pole and magnetic pole once again. geographic pole is the pole of the earth. Magnetic pole is the because of the magnetic property. A geographic pole hai. Magnetic pole will be here. Now this magnetic pole, again I am saying, this magnetic pole is changing. This magnetic pole is based on the bar magnet. If I'll see bar magnet, it will show north pole को क्या दिखाएगा, south. That will bar magnet, it will rotate like this. That is the first case was bar magnet I have shown. So in general, with respect to bar magnet, we said the magnetic pole, then it is north pole becomes south pole. That's what I said. Okay. Irregularity due to presence of clay, sir. Yes, presence of clay due to the action of water, running water. Please explain geographic pole and magnetic pole once again. Geographic pole and magnetic pole once again. I said geographic pole is that imaginary line, the point you have north pole, that is a 90° north latitude. But magnetic pole is the point where you have all these magnetic field, they got converged, they are converging here, magnetic into, they converge here, they are different here, 11.5° difference we are having. I have shown you. Previous slide क्या चाहिए, चलिए लीजो. Previous slide is this. Next one, please, geomagnetism again. Geomagnetism, geo mean earth, magnetic property of the earth, geomagnetism. Again मैंने कहा polar wandering and geomagnetism at a time tomorrow will do. A modern aircraft leaving Wellington Friday releases. Okay, same aircraft return from the Hawaii, leaves at the 6 p.m. 11. Can you please explain this? See, one in GC Leong it is given, it is wrongly given the answer. You see, whenever you are crossing the international date line, one day you are losing. Argillaceous and calcareous rocks. I'll come to this again. This particularly in what you call international date line. I got one questions you have asked to some of our people here. A international date line. This is the international date line, you know. International date line. There was a question by somebody, how many days it gives, how many time zone. See, there are, ye dekho, international date line, it is here like this. It is not a straight line. International date line is a zigzag line. Zigzag line you can see, this is the international date line. Coinciding with the 180° longitude. 180° के साथ coincide कर रही है. And here you see, here is a time zone, this part has a time zone, एक time zone इसका है, एक time zone इसका है, इधर एक time zone है, 3 time zone हो जाते हैं यहाँ पे. Internal date line, यहाँ से यहाँ तक में 3 time zone आ रहा है, 1, 2 and 3, देख रहे हैं, 3 time zones it is covering. So in your material wherever it is given, it is like 3 time zones in this way. If generally हम क्या करते हैं, 3 time zones, why we give? We give 3 time zones because I said this is a time zone, this is a time zone, this is a third time zone here. 3 time zones we have. This is one time zone. You see here 10 to 11, yeah, and this is 3 time zone, 1, 2 and 3. 3 time zones it is covering. देखो यहाँ तक है ना, यहाँ से यहाँ तक 3 time zones it is covering. That is what is given in your material. Don't worry about that. Now, if we will cross this international date line, when you will cross this international date line, there is a possibility of difference of 24 hours. Because day start here, then you will go in this way, isn't it? Again you come to this part, 24 घंटा लगेगा यहाँ से स्टार्टिंग है. सो वेयर इफ डे स्टार्ट्स हियर, सो यहाँ पे अगर आज का डेट है, आज क्या डेट है, आज जो डेट है, आज का डेट में अगर चलेंगे इधर, तो हम यहाँ पहुँचते पहुँचते हो गया नेक्स्ट डे तक आ जाएंगे. मगर यहाँ पे अगर इफ यू क्रॉस दिस ईयर, अगर आप इधर से इधर जा रहे हो, व्हाट विल हैपन, -1 डे होगा. दैट इज व्हाट इज गिवन. सो प्लीज check out this and calculate it. Okay, because a lot of questions you are having. Try this, or else you can send me this. I'll at around 9:30 p.m. so that I will give you the answer here on this. Why does increasing altitude widens the circular horizon? why does increasing altitude mean height? You see, line of sight जो होता है आपको पता है, if it is here, if you will go up, larger area you can see, visibility area, range will be wider. That's why horizon wide होगा, because your line of sight will be larger here, and here you have input the entire area, visual area will be larger one. That is the cause. सीधे बात, नीचे ऊपर से जाओगे कोई भी एरिया तो ज़्यादा दिखाई देगा ना. That is the cause, nothing else. Very simple thing. Why asthenosphere is low velocity zone? Sir, kindly explain it again. Because at the asthenosphere, you see, it is a gel-like layer. Neither it is solid nor it is liquid. So you know that S wave passes through only solid. So because it is semi-solid, so it is the S wave travel very slowly. First thing. Second is P wave passes through solid, liquid, and gases all. But P wave velocity decreases in the liquid and very less in the gases. So because it is semi-solid, so the velocity decreases here also from the crust while it goes. That's why both P and S wave velocity be less, and it is called as the low velocity zone. Okay, I hope it is clear now. Why does increasing altitude widen the circular horizon? Here again you asked me. See here, if we'll हमारा विजन कहाँ तक जाएगा बताओ, अप टू व्हाट एक्सटेंट यू कैन सी, जो साइट जो है अप टू इन डिफरेंट, इफ यू लुक एट इन ऑल डायरेक्शंस यू विल हैव लाइक यू नो इन अ सर्कुलर वे, होगा कि नहीं होगा. सो इफ फ्रॉम अबोव इफ यू सी डेफिनेटली अगेन इन अ सर्कुलर वे यू कैन सी अबोव. लुक एट दिस, इमेजिन द केस, increasing altitude, if it will have like rise in the altitude, definitely vision you will have widened, the circular horizon will be again also it will have more circular horizon because of earth which is also again first is your line of sight, second is the earth is also circular. What is the significance of solid upper mantle above the asthenosphere? Soil and semi density are equal? No, soil is less denser, semi is more denser one. What is the significance of upper mantle above the asthenosphere? Look at here, upper mantle above the asthenosphere, look at here. Upper mantle, this part you are asking about. This part only will have like in a crustal deformation during which we have different action, and whenever two plates meets, later on we will discuss about this. One plate subducted below this, so here you have melting takes place because of pressure and change in the melting point also. There also formation of magma chamber takes place, crustal doubling takes place, and all these are there. Plate tectonics will give you detail of this. What is the significance of solid upper mantle? Okay, igneous rocks are not useful for agriculture, then how Deccan Trap's cultivation is done? My friend, igneous rock, Deccan Trap you have region has black soil. Black soil is from the igneous rock. These are rich in titaniferous magnetite and montmorillonite minerals, which are very much useful, and they are mineral rich. These are, and they are very they have the clay property. They can retain the moisture for a long time. They are poor in nitrogen, humus and phosphorus, but rich in rest of the minerals. Okay. So they are, because of weathering they takes place. So during the weathering process mineralization takes place. That's why. Geomagnetism is created only for oscillation of nickel and ferrous. No. Geomagnetism has a general tendency, magnetic property of the earth, because of the differential movement of both metallic core. आप देखो ना यार, आपको पता है डायनामो कैसे काम देता है, आर्मेचर कैसे काम देता है, and the same process you will have. Could you please explain impact of geothermal energy more than impact of pressure? Yes. You see, in the inner core, if you will see here, the geothermal energy is more here as compared to the pressure. That's why, because with every 32 meter 1 degree Celsius temperature increases. With every 32 meter depth 1 degree Celsius temperature will increase. Every 32 meter depth 1 degree Celsius increase होता है. So think about this, 1 किलोमीटर में कितना हो गया, 100 मीटर में 3 डिग्री ऑलमोस्ट 30 डिग्री इन 1 किलोमीटर. थिंक अबाउट दिस. 2900 किलोमीटर में क्या होगा? So you have like very high temperature here. This leads to temperature. This is temperature more, so that's why it is molten. Now, if you go deeper inside, impact of pressure is more. So even if high temperature is there, they will not allow these particles to move freely. They behave like the solid. That's the cause. Inner core is solid. Okay. Explain gravity anomaly, isostasy only. Explain gravity anomaly. Gravity anomaly I am not discussing here. Please, I will discuss it whenever it requires in isostasy. Differences in gravity as per the calculation and final whatever you will get the anomaly. Why Japan is called land of rising sun but not the New Zealand? At that time Japan was the only powerful major country. That's why earlier we have given. Now it is definitely it should be Papua New Guinea or New Zealand, but it was not there earlier. What is the importance of magnetic poles? Magnetic poles influence the earth atmosphere, gravity of the earth also, and magnetic poles plays a very vital or very important role in every sorts of your life. Magnetic pole, you will be surprised to see this magnetic pole leads to even the direction up. You know about the ionosphere in the upper part. We have ions are there. They are also closely related with our magnetic field. Ionosphere in the upper atmosphere. While I will discuss the ionosphere part, troposphere, stratosphere, mesosphere, ionosphere, exosphere. At that time we will have a discussion about this again. Aurora australis, aurora borealis, they form how it is based on this. So magnetic pole has a greater impact on the atmosphere and the aurora, light in the winter night, light in the winter night in northern hemisphere and southern hemisphere. Northern hemisphere known as aurora borealis, in southern hemisphere aurora australis. Sir, region where we can find igneous sedimentary rocks. See, igneous rocks are found near volcanic part. No, old craton plate tectonics में आपको पता चल जाएगा ये plate movement में. Wherever you have volcano, wherever you have divergence of the plate, you have igneous rock. Okay, and wherever there is convergence of the rocks or there is form, there is metamorphic rock. What's the difference between P and S wave? My friend, as we have seen, P wave, primary wave, and S wave, secondary wave, their movement propagation देखो. The P wave move like this, but S wave move like this. Okay, so ऐसे जाएगा S wave. P wave will be like this. So आप दोनों में different, direction of propagation में थोड़ा different. Their energy is more in case of P wave, no doubt, but again primary wave more energy, but again it depends on what? The position where it is developed, the focus का position कहाँ है उसके ऊपर. Sir, I can't understand the first question. Homework, please explain. Okay, जरूर, definitely. See here, what is the first question? Give a detailed account on the physical condition of the earth interior. मतलब whether it's solid, liquid or gaseous, whatever is their state of the earth interior, in the light of seismic evidences. Seismic evidences mean behavior of the earthquake wave. Mean you have to draw the diagram showing the P wave path, S wave path, and how the refraction is there, and this shadow zone, P wave, shadow zone, whatever is there. So what we need to do is, if somewhere there is completely the wave, see, if earthquake is in this particular part, ये earthquake होता है, here is the focus, here is this which wave? This is the S wave shadow zone, S wave shadow zone you have to prepare. And for the P wave, same way we can do for P wave. P wave shadow zone, here also this is also P wave shadow zone, P wave shadow zone, this shadow zone. This is the differences here in these regions, the differences in this part, the differences, why it is suddenly changing its path, why change its path, why there is a change in the path. This thing shows that there is change in the properties of the matter, particularly solid or liquid, whatever is there. That's why the refraction के वजह से होता है. That is what you have to write this. Will give feedback on all these things. Okay. So these are certain things. So thank you very much. Do study. Any question, please WhatsApp me at 9:30. If you will do, it will be better, because after my classes I will be available for you people in the night itself. So WhatsApp me, I will definitely answer it to you if you require anything, any sorts of, if you have more problem. So this is something. So I request you all again, have trust and faith in yourself, give your dedicated efforts for this, and believe me, it is achievable for you. You need to do this very quickly. Mediterranean Sea located in Europe, but you said yesterday located in Australia, because did I say Mediterranean Sea? I said Mediterranean climate, not sea. Mediterranean climate, my dear, not sea. Mediterranean climate found in Mediterranean Sea regions, as well as Mediterranean climate found in South America, North America, Africa and Australia. Okay, Mediterranean climate I said. आगे सब समझ में आ जाएगा, कोई बात नहीं. So thank you very much. Give your best, my dear. Again, you go ahead with your preparation. Any doubt, any problem, anything, please give me an opportunity to explain it. You just, if you are not getting any answer properly, you please text me or WhatsApp me. Thank you very much. Bye bye. Have a nice time. Bye bye. Thank you.